In this course, you'll learn the basics of Godot for game development. This course is perfect for Unity developers transitioning to Godot, but it will also help people who are new to game development in general. Omar Zaki teaches this course. He is an experienced game developer and has created many popular Godot courses. You'll learn how to navigate the interface and build a simple Flappy Bird game.
Hi, my name is Omar, and I assume most of you guys, at least close to the update of this video, are here because of Unity. A lot of you guys are quitting Unity and have decided to pick up Godot, and so I have made this video, lengthy video, it's about an hour long, to help you transition into Godot. This video is not how to become a game developer. It does cover some basic topics of game development. However, this video is mainly focused on introducing you to the Godot engine. Not Gadot, whatever they say, it is Godot. So I hope you enjoy, and I hope you learn as much as possible from this video. This video definitely will not cover most of the nodes. It is mainly just how to navigate the interface of Godot and how to actually get started on your project. Hopefully, your transition from Unity to Godot is not too brutal. Or if you're not even transitioning, you're just picking up Godot and want to learn game development, this is the right place for you. This, again, is a complete beginner video, just how to pick up Godot. So I hope you guys enjoy this video, and I will see you at the end of the video. Our first step is going to be to get familiar with the Godot engine and actually making sure we have all the assets we need. So here we have our Flappy Bird assets, and we also have the Godot engine executable file. So here was my zip file for that. I'm going to delete that. I'm going to extract this. We have our file here. I'm going to delete this. We're going to launch the Godot executable. We're going to create a new project. I'm going to browse it and put it in my desktop. I'm going to name this Flappy Bird YouTube tutorial. Here on the left, we have 3 different kinds of renderers. Now for 2D, usually I use compatibility. For 3D, you would most likely want to use forward, and mobile is, well, for mobile, for very less advanced 3D graphics. As you can see, there's a little description of what everything does. So let's select none for the version control, because I'm not going to put this on GitHub. I'm going to now create folder, because we see here it gives me an error and is telling me to create a folder. Now I can create and edit. And here we have our fresh project. Now let's take a look at our interface. Here on the left, we see we have the file system. This is where all the files that we create with scripts and scenes and anything else will appear. This is also where we will be importing our file soon. On the top left, we see create node. Now this will change in a bit. However, this is where the node structure will generally be. This is where I edit and change my scene. We can also see the import tab is also on the top left, and we have a few other settings on the top above that. Now in the middle, as we can see a giant screen, we see the project tab. This is where we see the actual scene, and on the top right above that, we can actually change it to 2D. Now on the right hand side, we have inspector, node, and history. This is the inspector, but it's also the property panel usually. So when I change a node or an object in my game, the properties will be on the right-hand side. On the bottom, we have a bunch of other useful things, such as output, debugger, audio, animation, and shader editor. There's going to be a few other things that might pop up depending on what node you're using. For example, tile map or tile set can add an extra thing, which we will be doing in this video. Output is usually for things like print, which we will also be looking at in a bit. All right, so at this point, we want to actually import all our assets. So we're going to minimize the screen like this, and we're going to find our folder. So here's our Flappy Bird folder assets. All we have to do is really easy. We just take it and drag it into our screen. If we make sure we select this, drag it, and put it into our folder. It's going to say res. We just drag and drop it, and it should import. Now, we might instantly see a problem. Now, the first problem we see, I'm going to drag one of these pictures onto my screen. It's going to turn into a sprite on the top left. Here we see the icon for the sprite, and if I select it by clicking it, on the right, we see that it says Sprite 2D. Now, if I zoom in, we can see it's kind of blurred. So in order to fix this, we have to change the properties of this. Now, what we can do, I believe, in texture, here we go. In the texture property, we will go to the filter and select nearest. Now, if I zoom in, we can see it has become pixelated. However, I don't want to do this every time I import or add a sprite. So we're going to set the default. Now here by default, if we actually reselect this and click the loop, it'll say inherit. Now what does inherit mean? Inherit is going to inherit the default project settings. Now if we go to the top left and click project settings or project, we see project settings. If we click that, we'll go to down here. We can actually just search up filter, and we should find rendering textures. In the textures, we'll find default texture filter. At the moment, it is set to linear. We want nearest. If we close this, we now see, if we zoom in, it has become pixelated, and the filter on the right did not have to change. Now, the advantage of this is if I delete that and add another PNG, we can see that it is properly pixelated and not blurry. Well, the background is blurry, but that's just how the background is. So I'm going to delete this. And now we have imported out our assets and we have set the project setting. Now let's go back into our project settings and we're going to actually change the window. So let's clear the search. We'll go to window display on the left, and we're going to actually switch this to divided by 3 and then divide this by 3. And then we're actually going to switch these. So this is going to be 384 and this is going to be 216. So let's make sure we have these. And on the stretch, we're going to go to the mode and keep it as viewport, and then aspect, we're going to expand. And now we'll close this. And now we see that our blue window has changed. Now this is essentially a camera. If I were to play, nothing's going to happen because we don't even have a scene yet, but we'll actually do that right now. So let's go to create root node. We'll create a 2D scene. Because we want a 2D game, we need a 2D node as the paper that we draw on, essentially. This is going to be a piece of paper that we actually draw on and add sprites and nodes and other things to it. So let's Control S to save. I'm going to name this file world, and we see that it is saved as a .tscn. This stands for scene. We also see here that it's going to be recognized as other things, but we just need it as tscn. We'll save this, and now on the left, we see world.tscn has been saved, and if I click it, this opens. Right? It's already open, but that's okay. Now, if I click play, run project, or F5, we can select or select current. Select will open this folder, and we can select this to open it. And now we see our folder or our screen is right here. Now, if we want to change the actual size of that screen that just appeared, we can go back to project settings. And instead of switching the viewport and width, we're actually going to select advanced settings. And here on the bottom, below the viewport width, I'm going to copy this. And here under all the way at the bottom, we see window width override. Now this is going to be overriding the actual screen we see. This is essentially the pixel size that we see and play with in our screen. So make sure we take a look at the top right here. We see that this screen is approximately 250. Technically, it's 216. That's what we set it to. However, if we go to the window width override and multiply it by maybe 2, and then go to the height width override, and then multiply this by 2. We now have these settings. And if I click close, this did not change. However, if I click play, our screen is now a lot bigger. So that's all the override does. If you were making a mobile game, for example, this would not matter because on a mobile game, the screen will automatically resize to the Android screen you have or the iOS screen. On Windows, this matters more because that is the window that we actually play on. Now, I will let you play around with these values, do whatever you like, but these are the settings I'm going to work with. Now, one additional thing, if you accidentally select a different scene to play automatically, here we have run project. This will play the project completely from scratch from the very first scene. Now, let's create another scene. Let's create this scene just for the sake of having it. So I'll save this as Node 2D. If I right click this, here we go. Now we have this that says set as main scene. So now if I play, it looks the same, but it's now going to be running the Node 2D instead of the world. And I can actually confirm this by going to the left. When I play, I see remote and local. Local is the local things that I edit. The remote is the live version. Here we have root, and it also says Node 2D. We can confirm this by hovering it, and it says instance Node 2D. It shows us the file path. Now, this is because we have set this to play this on the main. Now I can stop this by clicking this on the top right or by clicking F8. Now I'm going to close the Node 2D, go back to my world, and now I'm also going to rename the Node 2D to world. All right, let's get started in actually creating something. So the first thing I'm going to introduce is something called rigid body 2D. Now, in order to add objects into our game, unlike Unity or some other engines you might have used, everything is already essentially preset. Now, in order to add that specific object you want, we go to the top left under Scene and click this plus button or Control A. Now we have this window that says Create New Node, and all these nodes are essentially objects. Here we can see the Node 2D, and it's actually organized quite nicely. Most of the things that are 2D will be under the Node 2D. If I click this, I can see a bunch of 2D objects. Now, instead of just looking through all this, I'm just going to use the search bar. I'm going to search up rigid body. Now, if I click the X, oh, it doesn't select it. So I'm going to actually find it for the sake of introducing just bodies. Here we go. It's in the collision object 2D. So here in the collision object 2D, we see that we have physics body 2D. We have static body, character body, and rigid body 2D. Now, rigid body is used for things like balls or things that need physics simulation, right? So I think the classic example is a ball, because a lot of engines like to compare those kind of physics. And I will just say right off the bat, if just in case you are from Unity, one of the main differences that at least I'm aware of the rigid body 2D in Godot, and just not even 2D, but just rigid body, the 3D as well, versus Unity, is that the rigid body in Godot actually simulates a real ball. So when you drop a real ball, generally it has momentum and it stops eventually. Whereas in Unity, the ball will keep bouncing to the same height. Whereas in Godot, it'll eventually stop and get to the ground essentially. Now, we're going to create this by selecting the rigid body 2D and create. Now here on the left, we see rigid body 2D, but we also have an error on the right. Now, if I hover this, it's going to tell us we just need a collision shape. So let's do that. Let's Control A or add a node, and we're just going to search up collision shape. Now we have a lot of collisions. We need a collision shape 2D. Collision polygon can also work, but collision shape is a little easier. So let's add that. Now let's zoom in to this point, because that's where it is. We can see it by either hovering or just selecting it in general. It's already selected. Now, if I give it a shape on the right, I'm going to select a circle shape because my bird is going to be a circle. Now, we can see that there's not really anything here. So let's add our player. So let's go to the left in our files and add our player. So we have 3 birds we can add from. I'm going to add the red one. We can see that it's automatically turned into a sprite. Now in Godot, there are quite a few ways to animate things. So this gives quite a bit of flexibility in how we want to do things. So we can either go to animation here and type in the H-frame 4. If we do that, it'll take the frames that we had and turn it into this. Now there is something called animation player, which I'm not going to get into, but it's actually a very powerful tool in Godot that helps us animate various things. So if I wanted to animate from 0, 1, 2, 3 for a frame, it could do that. However, I'm going to do an easier method, and I'm going to use something called animated sprite. So I'm going to go to my rigid body, select my rigid body. I'm going to add a node and search up animated sprite. We see animated sprite 2D. Let's create. Here, it's basically telling us we need to create a sprite frame. So on the right, let's go to animation, sprite frames, new sprite frames. Click this. And here we have a new selection on the bottom that says sprite frames. Now here it says default, but I can double click this and rename it to fly. Now here it's already automatically looped, but here we have no frames. So let's add some stuff. Now you could drag and drop, but this adds a frame. This is frame 0. That's not exactly what we want. So let's delete that. What we want to do is we want to add these 4 frames into this as separate frames. And luckily enough, Godot can do that. If we click this rectangle button little thing, we'll find that this pops up and we can find our sprite that we want to add. I'm going to do the blue one actually. And if we zoom in by holding Control and zoom in, we're able to zoom in. And on the right side, it used to actually be on the top, but they changed it so it's on the right. I actually don't like that. I like it on the top, but that's okay. We're going to go to horizontal and select 1. Nope, sorry. 4, and then vertical we'll do 0 or 1. So now we can select all these and we can see that the numbers actually correlate to the order. So if I did this, it would be a different order. Now we can just unselect it all and then select all and it'll do it like that. That's probably a bit easier. So select all on the top or select none and then select all. So make sure we have select all and we add all 4 frames. And now we see all 4 frames have been added. Now I can play test this by just clicking this play button and it automatically loops. Now what I'm going to do is I'm actually going to automatically play this. So that way it plays on when I play the game. Now if I run the project, nothing is really going to show up. So what I'm going to do is I'm actually going to take my rigid body and I'm going to move all of it by, instead of clicking and dragging, you can see here I've only moved the sprite. What I can do is either, there's a lot of options. I can either take these 2 by holding one of them and then shift and selecting the other, or control, and then I can lock it. And now I can select my rigid body. Or if I don't want to do that, which I usually don't, I can just select my rigid body. I can click this guy, the move mode or W, and now I can just move the rigid body from anywhere. And it's a lot easier to move things around. Now, if I play, again, nothing. That's very interesting. Let's find out what's happening. Most likely it's just falling before we can even see it. So let's go to the remote and see what's happening. Ooh, I see what's happening. We're not playing the correct thing. So let's make sure we select this as the main scene, and I'm going to delete the other node that I made. There we go. There's our birdie. And as we saw, it automatically falls. It has its own built-in physics and gravity that it just automatically falls. We can find it by by selecting the rigid body 2D and going to the right side with the properties panel. We see linear and angular velocity. We're going to actually play with both of these in our script in a bit. So I'm going to unselect those. We don't want to select anything. Here we see the transform. This just shows us the position, rotation, scale, and skew. Skew is actually new in Godot. So if you would like to play around with that, you can see what it does. It's kind of interesting. But I'm going to leave it at 0. we're not going to really play around with too much. So now what we're going to do is we're going to actually add a script to our bird. So let's actually rename this to bird, and then add a script. As you might have assumed, the script is up here on the right, or on the left, sorry, with the little paper thing that says has a plus button. If I click that, it'll prompt me to attach a node. Now there's a few options. The language I could change before. There used to be, don't remember what it was called, but it was like another GD thing. But either way, you can also, I believe, import C# into Godot. I don't know how to do that. I've never tried it. I've never done it. But there are videos out there that you can find that will allow you to do that if you prefer C# over GD script. Now, I will give a, not warning, but I guess just a general knowledge thing, is that GD script is basically Python. If you know Python, or if you have an inkling of what how Python works, you'll be fine. GD script is very similar to Python. It's essentially the same, but GD script just has its own built-in functions, which is very useful, which we're going to be taking advantage of. Now we see here the inherits. This we'll actually see what this does in a minute when I create this, but what also matters is the template and the built-in script. Template is actually new, which is cool. There's no template, real template for the bird or the rigid body. However, for some other nodes, there are some templates, but either way, we're going to leave this as node default. For the built-in script, this, if I select it, essentially I cannot find the script in my files. It is a built-in script into this node. Usually that's not what you want to do, because if I create this, let's create it. Here we go. If I hit Control-Shift-F, I can find anything in my file. So for example, let's say rigid. It will now show me on the bottom the find rigid, and it'll show me the things that have rigid in it. Now, if I had made it built in, so let's actually take this out and delete this script. If I do the same thing, make it built in, and let's go to output and then say rigid, nothing shows up because it's built in. It's a built-in script that we cannot search through our files. So let's make sure that we have it not built in and create. And here we have on the right left as well, we have an unsaved thing. This is just the other built-in script. It's a little wanky sometimes, but we're just going to use this. All right, so in our script, we want to take a look at the code that we have so far, because right now it's not much, but what's happening here is it's going to extend the rigid body 2D, which is basically a class, which is rigid body 2D. It looks like my head says low, but I'll charge that in a minute. Here we have two functions, the ready function. It's called when the node enters the scene. And we have the process function, which is very useful, but we're not going to use that just yet. We're going to create a new function called function input event. This is a function that checks for any sort of event. So if I print the event and I go to output on the bottom left and I play my game and I start moving my mouse or even clicking a button on my keyboard, anything. This is any sort of event. Now the question becomes, how do I specify this to a certain type of thing? Well, I can say if event is input event mouse button, then we'll print the event. Now this is what this is going to do is if I restart the game, it will only take something if I click. Even if I move my mouse, it won't input that because that's not a mouse button, it is a motion. So if I actually control and left click on this, it will bring me to the input mouse button document, and I can even click the online document. I won't now. There's also the search help, and we can kind of look at what this stuff has. I'm not going to. I'm gonna actually, I already know, so I'm gonna teach you. So when I look in my game, let's restart this. If I left click, we see that the button index is 1 and the button mask is 1 and 0. That means I clicked down. So if I click down once and then release, the button mask is 0. If I right click, the button index is 2. So now we can actually check for which button I'm clicking on my mouse. And I can do that by saying if event event.buttonIndex is equal to 1. So we're taking the event and looking for a property. ButtonIndex is a property of the event. So the event here is the thing that I printed. So this is the entire event, but I only want the button index, and I do that by saying .buttonIndex. Similarly, we can do event.mods or .pressed or anything else. You can even check the position by doing event.position. Okay. So now we want to add linear velocity to our player every time I click. Now, how can I do that? Well, there's something called linear velocity. However, you'll see in a second. So if we want to change the y, maybe let's subtract 150. So in Godot, when we add or subtract to the y-axis is actually negative in the upwards direction. So if I look very closely on the left, we can see that this says 50 here. And if I go up a little bit, this is negative 50. So I want my bird to go upwards when I click. And I do that by subtracting 150. Now, let's try this. Oh, that's a little weird. That's not exactly what I want. So what we're going to do is we actually, setting it like this is very strange. Now, every node, not every node, but most nodes have a built-in function for these type of things. Now, this one is set linear velocity to this velocity. Now, I can't just pass through a .y, I have to give it a vector 2. So vector 2 is just an x and y coordinate. Now the x, I don't want it to move in the x direction because that's right and left. I only want it to go upwards of 150. Now, calling self is the same as not calling self. So if I do this, it's the same as saying self dot. I just like to get into the habit of doing self dot and then the function, just so it's a good habit. So that way you see what all these things are doing to what, right? So now we know that we're setting the self to the linear velocity. Now, if I play, we can see we have a little bit of a jump. It's a little better than it used to be. Now, to make this a bit more fun, we're going to do the same thing, but we're going to say set angular velocity to negative. Maybe let's change this to -1 and see what that looks like. And now you can see our bird is kind of flipping. I think I'll keep it to -3, so it's a little quicker. Now we can see our bird is flipping like that. So it looks a little cooler. Okay, you also have the option of playing the fly animation only when you click. So to do that, we can go to our animated sprite, make sure it's selected. We have it here on the bottom. We're going to turn off the autoplay and we're going to turn off the loop. Now what we can do is we can take our animated sprite and drag it into our script. And it gives us the path to our script. Now, what does this do? This essentially gives us access to the animated sprite. So now what I can do is I can call something from that. And I'm going to say play fly. It's going to play this animation for us. Now, we see that there's a bunch of other properties that I could put, but I'm just going to leave it as fly. This will work fine. So now when I play, my bird is not doing anything. And it's very subtle, but now he only plays the fly animation when I click. Cool. All right. Now we've learned how to access animation sprites. We've learned how to change properties. Now we're going to edit our scene a little bit. Let's go to our main scene. And I want to add something called a parallax background, which is up here. Parallax background. We're going to create this. And what is this? Well, it's basically a parallax background layer. So let's add another node and we're going to add a parallax layer. Now let's take a look at how this works. If I take my background, I'm going to add this one. Take this background, transform it to 1.5. I'm going to move it down a little bit. And in case you're wondering, if you want to turn on or off the grid snap, which is useful, you can easily do it with Shift-G or this guy right here. All right, so I'm going to move this in the middle, and I don't want this to move. So I'm going to put it right there, above the parallax layer. Now, in the layer, we're going to add something. We're going to add our type. We're just going to add this guy, just to test it. Now, you see when I tried adding it, it just added it over here in the world. We want to move this to be a child of the parallax layer. All right, we now have a pretty complicated setup on the left. We basically have the parallax layer, a child of the world, which is fine because we are playing in a 2D world. We have the parallax background, which is a parent of these two nodes. And the parallax layer is what we're going to use to move. So let's go to our parallax background, and we're going to add a script. We're going to have it built in. And you don't have to make it built in, but it's up to you. We're going to edit something in our process function. We're going to change the scroll base offset .x, and we're going to subtract scroll speed times delta. Now, what's scroll speed? Well, we have to give that variable into existence because it doesn't exist. So let's say variable scroll speed is equal to 0. Now, in Godot, variables are just called variables. Now, if I want to specify a specific variable to a type, here, right after, I think it's here, let's find out together, we can say int, like this. And this will specify that it's an integer. Now, either way, it doesn't really matter because Godot is actually smart and will automatically kind of assume what this type is. So here, when I just say equal to 0, it's automatically assuming that it's an integer. Now, this is nice, but I'm going to add something called export. We're going to export variable scroll speed. Now, what does this do? Well, if I go back to my 2D scene and I click the parallax background and I look at the properties, well, now I see it says built-in script, and then right below that, it says scroll speed. And now I can change that to 50 or whatever number you'd like. Now, if I play, our background is moving. The parallax background is starting to move, which is great. That's really cool. So this is pretty neat. One more thing that's usually used in parallax background is called mirroring. Now, if I want this same background to show up, I can mirror it by maybe giving it 100. Usually you want to give it the same number that is this one, so 216. Zoom out. And now if I play, it should duplicate. So forget the bird, we don't need him. We have that one, that's the second one, and there we go, there's our third one. Right? Even though we didn't draw a third one, it is now showing up in our game, right? And it's going to keep mirroring forever. So that's very useful, but that's not exactly what we need. But it was a good thing to see what this is. Now let's delete this parallax layer, and we're going to add something called a tile map. Now Godot is actually pretty unique in their tile map because it's a really powerful tool that not many other engines have. So in our tile map, we see tile set on the right side. Up here, it says empty, so we're going to click it and give it a new tile set. Now on the bottom, we have tile set and tile map. In tile set, this is where the editing happens. Any sort of editing to my tile map is going to happen here. Any sort of application that I actually put into my game will happen in the tile map. Hopefully you understood that. If not, that's okay. We're going to learn this with an example. So clicking our tile set on the bottom, we're going to take the tile style 1, because this is the ground, and we're going to drag this in. We're going to click yes, and we're going to scroll down a little bit. And we're just going to take a look at here. Now, Godot 4 actually just changed this, so it's a little, I don't know if you want to call it easier or harder, but it's really cool. So pay close attention. We're going to go to the top right. We're going to click tile set. On here, we're going to click this tile set. Now these new properties will show up, and we see physics layer and a bunch of other things. The only one we're going to focus on right now is physics layer. We're going to click add element, and this has basically allowed us to create a physics layer. So now we're going to unselect that and close this. We're going to go back to our tile set because remember, if we want to edit anything from our tiles, we have to do it in the tile set, right? So now let's go back to Paint. Actually, I'm going to give a quick demonstration as to why we need to do this. Let's go into our tiles, into tile map. So make sure we're in tile map and we see tiles. Here we can select a tile and now we can just draw. Now, okay, if you have move mode selected, it won't allow you to draw. You have to have the select mode selected. And now we can see the tiles right there. So let's draw along the map and let's maybe put this one. Now we can also paint or use a rectangle like this to make it a little easier or quicker. We'll make this easier for us. Now, if I play, what's going to happen? Well, my player just fell right through. That's not what we want. We want an actual physics layer. Now, in my tile set, again, we're going to go back to the tile set. We're going to go to Paint, Paint Properties, and we're going to select the physics layer. Right here, we have physics layer. Now, if we did not create that physics layer, you will not see this. If you did not see this physics layer, please go back. You missed a step. Okay, so let's click this physics layer. And now we have some things here. Let's drag this up a little bit so we see everything. Now here, it's actually very neat because we can specify the physics layer for all of these tiles. Now I'm just gonna select all of these because it doesn't actually matter, but for future reference, you can actually change these points and change the collision. See that? Very cool. So I'm not going to go too much into detail about tile maps. I actually have a relatively good video on tile maps. It's about 23 minutes long and you can check it out. It's in my channel somewhere. You can find it. But there are a lot of tutorials on tile maps. So we're going to just do this and let's play. Let's see what we have now. Bam, he hit the floor. But we can see that there's a little gap. Why is that happening? I want you to try to take a guess as to why this is happening. So pause the video and try to figure out why there's a little gap there. Hopefully you've unpaused. Well, if we scroll down into our bird, we see that the physics layer of our bird is this big. So it's working how it should. So if we select our collision map shape, we can see here, if I try to drag this up and down, it's not working very well. And that's because we have the grid snap turned on. So let's turn that off by clicking Shift G or just clicking that. And let's pin this down to fit our bird properly. Cool. So now when I play, it works as it should. Awesome. All right. We now want to add a way to detect if we hit the floor or the pipe in the future. So right now we have the tile map called tile map. We're going to rename this to walls. This is going to represent the walls or the floor. In fact, actually, I'm just going to rename it to floor. I don't know why I renamed it to wall, but floor is probably more appropriate. Now in our bird, we're going to add a new node called area 2D. So if I add a new node, add this node called area 2D, and now it's part of our bird. And then we need to add a collision shape, which we can actually find in the recent as well. Or you can just search it up, whichever one you prefer. Now we see that it needs a shape. So let's actually zoom in here because this is important. When we play with area 2Ds with collision shapes, with the actual body or rigid body, if this area 2D is smaller than this collision box or the same size, I believe it becomes inapplicable and it basically can't detect anything. So you have to make sure the area 2D collision is bigger than the collision shape of the actual rigid body. Okay, let's zoom out. And now in our area 2D, we're going to go to the top right. We have inspector and then something called node. Now node is where all our signals will be. There's also something called groups, but there are a lot of videos about that and you can check that out. Groups is completely separate from signals, but we don't have to worry about it right now. We're going to focus at the signals in general. So let's take a look at what sort of signals exist. First of all, it's important to note that these signals here are all specific to the Area 2D. These are built-in signals or functions specific for Area 2D. Now, there are other signals that are general for other things like node or canvas item or collision object or object on the bottom. And in fact, if we go to our bird and select this bird instead, we see there's different signals, but these are all the same. That's because they all inherit the same type of node. Now let's go back to our Area 2D. We want to connect a body entered. This will basically look for anything with a physical body. You can see, you can read it, and it says tile map in there. So we're going to double click this, and if it'll actually automatically prompt us to select this script of the bird. Now, if it prompts you to select something else, we make sure that it's prompting us to send the signal to the bird. Let's connect it. Now we have this signal. So what is a signal? What is this thing? Well, when this bird in the Area 2D, specifically the Area 2D, hits anything, the signal will proc whenever a body enters. Whenever a body enters this area, this signal will proc and basically gate and say, hey, something happened, right? And what do we want to do? Well, first, let's print the body. Let's see what it says. Let's print the body.name because the name is actually a property. So here we renamed it to floor. It should print floor if we hit the floor. So let's play and see what happens. So it says floor and bird, but why does it say bird? Well, that's because the Area 2D actually collided with the collision shape as well. So what we're going to do is we're going to add a if statement that says, if the body.name is equal to floor, then we're going to queue free. This is basically going to delete our player, our bird. Oh, there he goes. He got deleted. Cool. We have a relatively somewhat working game with no pipes, and we can stay alive, and it works pretty well. And if I hit the floor, I die. All right, so let's start adding some pipes because, well, this isn't fun without any pipes, right? So let's take a look at how we're going to add this pipe. Well, I want to actually add a new tile map. And in this tile map, we're going to go to the tile set, new tile set, click this, go to tile set here, and we're going to add whichever pipes you want. There's this one. I'm going to add this one. And there's also this one, which you can add, I suppose. I don't know. Actually, I'm going to add the bottom one because I think that's the one I used in my reference. So I'm going to go back here and delete this by clicking this. And now I have the pipe style. Actually, one more time, it should. Now, one thing I will say is you will notice the ID changes. And this is important for later, but at the moment, I'm just going to make sure that the ID is 0 to stay consistent. Okay, now we see here that the tile set is a little weird. It's a bit different. Now, what we want to do instead is we actually want to change the X and Y texture. And we can do that by going down here and typing 32. Oh no, sorry, 32 for the X, but 16 for the Y. And now we can select this entire thing. We also want to do the same thing for the tile size up here. So we're going to say click 32. Now we can select a tile like this. Now let's go to tile map and add it. We can see that we can actually add a tile. Okay, so I can do this. You can delete it by right clicking. Let's add a long pipe here. That. And we can do that. And now we have a pipe. Let's also add a physics layer. Now I want you to try this. Remember how we added the physics layer and added the collision. So I want you to pause the video and try this and give it a try. Add an element. Go to tile set. We're going to go to paint, physics layer. We're just going to select all of these. You can see here that we can even edit it here. I'm not going to care too much about the tiny collision here. Like you could do this if you'd like, if you are very specific about it. I guess I just did that. But yeah, so you can do that. And now the collision is very specific. All right, so now we have this tile map that doesn't move, right? Because if I play, it just stays there. Now, usually you would think that we want the bird to move forward, but what we're actually going to do is we're going to rename this to pipes. And then we're actually going to attach a script to this. We're going to not make it built in this time. Let's create it. And in our process function, we're just going to add something very simple. We're going to say position.x minus equals 60, which is basically speed, times delta. Now let's go back to our 2D script or 2D scene and play. Now we see that our pipes are moving. It looks like our bird is moving towards the pipe, but the pipe is moving towards us. And I collide with the pipe. Now what we can do is go back to our bird and add it. I want you to try this. Add a check to see if you can destroy the bird when you hit a pipe. Pause the video, give it a try, and unpause when you're done or confused. All right, so all we're going to do is I'm going to duplicate this and type in pipes. So now when I play and I hit the pipe, my bird goes away. Cool. So in our script, we actually want to randomize this. Now, how can we randomize this? Well, I have created a relatively complex script that you probably shouldn't do, but I've decided that I'm lazy and I don't know. I just like doing it this way. So let's take our pipe and we're going to actually save branch as scene. Nope. Yeah, wait. Yes. Yeah, I was right. Okay. I'm going to save the branch as scene. And now this thing appeared. It says open an editor. But what is that? What does that mean? Well, what we can do now is we can actually take this and delete it. Now don't worry. It's not gone. We actually have it over here. Now in our pipes, we can see that we have our pipes, but over here, it's not here. So first of all, we want to be able to spawn in these pipes, and then we also want to randomize this gap, essentially. Now, let's look at the randomization first, because that's a little lengthy. You don't have to understand the code too much, but basically, first of all, we have to, let's remove the tile set or the tile map here. Let's go to our tiles, or pipes. Now we're going to randomize this in our ready function. So first we're going to say, set the top pipe. And then we're going to create a random variable between 1 and 15. And we do that by saying variable random range top is equal to randy range 1 to 15. And then we're going to for loop in range of randy range top. Now, I'm going to show you another way to for loop, but this is one way. And then we're going to do something called set cell. This is going to set the cell on our map with a bunch of these numbers. Now, what do these numbers mean? Well, let's take a look. So if I say set cell, sorry about that, we have a bunch of inputs. We have layer, coordinates, source ID, and a bunch of other things. Now, if you want to understand this more in depth, again, I have a really good video about this on tile maps that you should definitely check out. Tile maps are a bit, I wouldn't say complicated, but a little more advanced, and it can get very difficult to wrap your head around it if this is your first time using it. But for the sake of getting this to work, we're just going to copy the code over. And this will set the bottom two cells, and then we're going to set the bottom pipe as well by doing this. Now in this for loop, we are not saying in range, we're just saying in 15. Okay, we have this code. If I play, oops, I have to play from the pipes. I want to check the pipes if this works. Now how can I do that? On the top right, there's run current scene. This will allow me to run this current scene, which is called pipes. So if I click that, we now see this. Awesome, we now have a randomized pipe. Let's stop and then play again to see if it is randomized. It's a little different. Cool, it's very different. Okay, so we see that this works. If you would like to try to understand it, I would give you kudos for it. However, I'm not going to go through the logistics of this. Again, I have a lengthy video about tile maps that explains most of this. It's pretty neat, and it's on isometric tiles as well, which is a bonus. But it works relatively the same. So let's go back to 2D. Let's go to our pipes. We're going to close this for now. We're going to go to our parallax background, make sure this is selected, and we're going to add a new node called timer. In this timer, what is this timer thing that we just added? Well, it's literally a timer. It will just start whenever we want it to. In fact, there's a property on the right that says auto start. I can click on, and this will automatically start it when I load the scene. Now, I'm going to explain to you what we want to happen, and I want you to give it a try. We want to connect a signal from this timer to our parallax background script, and then we want to spawn our wall. Now let's go look at our script and create a function called func_spawn. And I'm going to help you create this function. And then I want you to try to spawn them in yourself. Now, in order to spawn something that is from a separate scene, I think it's a little easier than Unity. We do something called onReadyVariable wall, or we'll change it to pipe. And then we're going to preload it. We're going to say preload and then give it the path. Now, what is this path? Well, this is the path of the pipe. Well, I called it wall in my reference, but here it's pipe. So if I take the pipe that I just created and then I drag it into this preload, it will give me the path for it. Alternatively, you can also right-click the pipes, and there should be copy path. Control-Shift-C. Now, in our function spawn, we're going to do something called variable wall temp. And then we're going to make it equal to the pipe.instantiate. And then we're going to say add child, because instantiating it doesn't actually add it to our scene. It just creates the object. Now we're going to add the child into our scene. And that is it. That is it for the spawn. Now I can spawn it in the ready function, for example. Let's do this, and let's see what we get. Well, there's our first pipe, but we want it to keep spawning pipes, right? So how do we do that? Well, hopefully you figured this out by now, but in our node on the top right of our timer, we click this, and there's a node signal called timeout. And you can see here that it's trying to connect it to our bird, but we don't want that. We want it to connect to our parallax background script. So let's connect that to our parallax background script, connect it, and we're going to call the spawn function when the timer runs out. Now let's play and see what we get. Oh, there we go. Now we have a bunch of pipes. Ooh, that's not exactly what I wanted. Well, let's go to our parallax background, go to our timer, inspector, and first of all, let's change the wait time. Now, the question is, why did the bird not get deleted when I hit it? Well, because let's actually play, and I'll show you why. We can look to our remote, and if we go to our world, parallax, we can see we have pipes, but then it's adding a bunch of other things that just says tile map. Tile map 1, 2, 3, 4, 5, whatever. Well, that's not what we want. We want to make it equal to pipes. So let's go back to our parallax background, and we're going to take our wall temp, and we can actually take the dot name, which is a property, and rename it to something. We're going to rename it to pipe. Now, or pipes. Now this might work. Let's play and take a look in our remote section. Doesn't seem to work. Now, why is that? The reason why it wasn't working is because in our pipes, we were renaming it every time to the same thing, but it wouldn't do that because we already had one that existed with the same name. So what's an alternative? Well, we're going to use something called in, but first of all, we're going to create something. So in our pipe script, we're going to create something called variable wall, or we'll say wall. Now we're going to save this. We're going to go to our bird script. And in here, what we can do is we can say if wall, I think it has to be capitalized. Yeah, it has to be the same. So let's actually make this lowercase, and then we'll make this lowercase as well. We'll say if the wall is in the body, then we can queue free. Now we can delete this first of all. But this is basically checking to see if the property is in that wall or the body that we just collided with. So let's play. And now it should work relatively fine. Let's test this one more time by going to the second pipe. And there we go. All right. We are almost done. We just have a little bit more. We're going to create something called a global script. Now, how do we do this? Well, first of all, let's create a new script. We have two options. We can either go here, right click. Oh, I guess they removed that. I think we can go to File and say New Script or Control N, or we can go to the res file on the bottom left, create new, and create new script. We're going to create something called game or global. And in this global, we're going to remove all this and say variable point. We're going to set it to 0. This is the points that our player is going to collect. Now, in our pipes, we're going to create an area 2D that is going to ding or give our player a point every time we hit it. So let's create this and add a collision shape. Now, how are we going to make this work? Well, it's actually pretty simple. We just have to create a long rectangle. We're going to move this all the way to the right where the pipe should be, and we're going to make it relatively skinny. Now we're going to go to the area 2D and say if body entered, connect this, and we'll say if bird in body.name, because the bird is not a variable, but it's the name of our bird, right? So now let's go back to our pipe, and we're going to say global.points plus equals 1. However, this should error. There we go. Not declared in current scope. Now, how do I make this global? How do I access the script from this script? Well, on the top left, we go to our project settings. This should open up. Auto load. We go to auto load right here. This is where we can auto load or globalize scripts or even scenes. So if I click this folder button, this guy will pop up, and you can see I can actually select the scene too. However, we're just going to select the global script and open this. Now it says the path. We're going to add it. This is the name of the script to access it. We're going to close it, and this should work. Should unerror. Sometimes if it doesn't work, what we can do is close this and play it again, or open it, and there we go. Now, in my world, we have no way of keeping track of the game points. So let's add something. Let's go to our world and add a label. This label is just a label. It's basically text. So if I go to the inspector and add text, I can write a bunch of gibberish, but that's not what I want. I want to create a script onto this, and we're going to say self.text is equal to string, because I'll explain it in a second, global.points, because we have to convert this points into a string because this is actually an integer and text is a string. We cannot set a string with an integer. It has to be a string. Okay, so this should allow us to show how many points we have. So let's play. And we see on the top left, we have the points. And every time I pass through the pipe, it increases the point. And if I die, it should not increase the point, and that's it. All right, that is pretty much the end of this series. I hope you enjoyed it, and I'll see you guys. Congratulations, you have finished this video. The mini course. If you guys enjoyed this course or little video I made, please subscribe, share the video with your friends or other Unity developers that have not transitioned yet. What else? If you guys liked my content, I'm going to be working on a course coming up soon. It is going to be a really, really big course consisting of not only how to master Godot, but also game development and getting started in game development. It is not out yet, most likely. It's going to take me a while to get it out. However, if you would like to support me on that and my development of that course, I would appreciate it to either support me on Patreon, or I will have a Kickstarter soon. So please subscribe to stay updated on that. Also join my Discord, which will also be in the link down below. Again, congratulations for finishing this video. It was pretty long. Hopefully you can continue on with this project and build on it. And who knows, maybe you can release it. Probably not, because the assets are, Flappy Bird. But that's okay. I hope you enjoyed making your first game in Godot.